This video is a bit special. Alright, it's gonna talk about the optimum angle. Alright, optimum. Yeah, you give me a while. Key takeaway is only this sentence. Optimum angle for fibers to be oriented for filament winding is 35 degrees to 55 degrees. Alright, so this is your cylinder. Alright, so if you to have a fiber like this is actually I think 90 degrees. So you're gonna wind it in a certain 35 degrees direction or 55 degrees, maybe slightly I think you get what I mean, okay? So you need a certain angle when you wind your filament, or the term filament, if you think about it, is actually your fibers. Alright, so it's just the meaning of that lah. Okay, so why do we come about this? Alright, so this expands. If you are interested, you can just continue. If not, you can just leave. The only key important thing is this thing, or this sentence. Okay, so over here, this is your cylinder. Okay, and this is your cross sectional. Alright, it's a cross sectional. And if you think about it, actually it relates to your mechanics. You can come to my channel, alright, and you go to mechanics. You go to created playlist, you go to Sem 3 Mechanics 4N, alright, and then you Control F to find hoop stress. Alright, and yeah, you'll most likely get this thing over here. Alright, deriving stress equation for thin wall spherical vessel. Alright, derive stress equations. So these are the, I think you can just take note of this one. I think these two videos will be good. Alright, because for so I assume that you know something. Alright, and therefore there will be a hoop stress and a longitudinal stress. Okay, so the sorry, the hoop stress is talking about a stress acting in this direction. Okay, so if I have this certain particular cross section over here, alright, this cross section, okay, so the hoop stress is acting in this direction, is acting going around the circle. Okay, while the longitudinal stress, or we call it the axial stress, is talking about the length, the stress acting along the axle of the material. Alright, along this thing. Alright, so there will be an axial and a hoop stress, and therefore if you were to go in this direction, no sorry, I should go into this direction. If I were to look into this cylinder, alright, this is actually the axial stress, this is your hoop stress. Alright, going along the cross sectional of your cylinder, okay, your hoop stress. So there will be a graph, alright, this thing, alright, your strength and your fiber direction in the x-axis, okay, and you have your so-called your axial stress. Your axial stress is coming in this direction, alright, while so this is your axial. Alright, and you also have this thing over here. This is your hoop stress. Okay, so therefore the intersection points all over here, okay, is actually somewhat is over here, and then there will be a somewhat a criteria line, alright, or a limitation line, alright, where I would believe this is 35 degrees, this is 55 degrees. Alright, may not be necessarily a straight line, that's what I heard, but the straight line is an ideal case over here at this case. But somewhat the regional is actually over in this region, so it's approximately 35 degrees to 55 degrees. In between will be good. Alright, so these are the things that is trying to say. Okay, so I believe you need to know how to draw this graph if possible. Over here, I actually click. Alright, you can actually come to the strain to failure analysis of composite. Alright, there's only 3 pages. Alright, and you come to the last page reference, you click the link, you'll come to here. Alright, which is a very powerful link where there will be a graph. As you can see, one by one start. So over here you see it tells you this is how the stress of a fiber looks like. Then this is how the matrix looks like. Alright, and this is how the where the cracking starts to occur. Alright, and things like that, and how the composite, and when will the composite fail. Alright, this is the line, that particular line, green line. Okay, so that this coming out, this line is actually the one that is composite failure. Over here, this is start to crack. Alright, so in between your fiber and your matrix, this is where the point where it cracks. Alright, things like that. Okay, but I'm not going into details because it's quite a lot of stuff going on. Alright, but he recommend you to read these pages. I think in the future he will go through, but since I don't think you will go and read. Alright, so you can take some pictures in the future if you want to know, in case that he didn't actually talk about it. So I'll slowly go through this page. Yeah, and you can read it up yourself. Alright, but nonetheless you can click this link. Alright, just copy this link and then you can just come to here and it should be fine. Alright, and therefore I think this is it. So yeah.